Welcome to homework help for lesson 8.1 on SOH-CAH-TOA. The problems that we'll be doing from the homework are from numbers 1, 2, and 3. So we're going to start with some quick notes and then we'll jump right in. Okay, first of all, we're going to master our tools, as I like to call it. These are our formulas and our definitions, without which every problem is going to be incredibly difficult. But if we know these and we commit them to memory, or at least have them in front of us as our notes, then each problem will go very, very quickly and we'll be much happier. So, before, we used to use SOH-CAH-TOA. Sine is opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent is opposite over adjacent when we're talking about triangles. This is no longer the case for us. That still is true, but we're going to use more sophisticated, more flexible definitions that we can use in Algebra 2 and in higher level math. So from now on, you're going to remember that sine theta is equal to y over r. Cosine theta is x over r, and then tangent theta is y over x. There are different ways to remember these, so figure out what works for you. And then lastly, we have this right here, x squared plus y squared equals r squared, and that's going to be like our updated version of the Pythagorean theorem. So that's given two sides. This is the relationship between three sides of a triangle. Instead of a squared plus b squared equals c squared, we're going to use x, y, and r in all of our formulas. So let's talk about what it actually means to talk about y, x, and r. If I gave you something in the first quadrant, so this is quadrant 1, right around here. If I give you something in the first quadrant, the way we're going to draw these angles, so first quadrant could be anything between 0 and 90. If I say 30 degrees, 45 degrees, even 60 degrees, 87 degrees, these are all in quadrant 1. This is how we're going to draw. We're going to extend our angle, so this would be like maybe 45 degrees, let's say. And then from there, we drop the perpendicular always to the x-axis. So pay attention, this would be incorrect, very common mistake. People draw to the y-axis. This is y, this is x. But that's not how we're going to solve these problems. Always to the x-axis, you're making a right angle. So the angle inside our triangle is, and at the center, we're going to call it theta. So if I'm interested in sine of theta, then usually I would go opposite over hypotenuse. But I promised you that we have new labels. So see if this makes sense. The distance that I travel on the x-axis, so this leg, that would be our x side. The distance that I travel up and down, that would be y. And then our hypotenuse has a new name. We're going to call it r. So when I talk about x, y, and r, x is going to be the horizontal side, just like the x-axis goes left to right. So you're not going to ever choose the up and down for x. You're going to choose the left to right side. For y goes up and down just like the y-axis does, so it'll be the up and down side, or the vertical side. And then r is always our hypotenuse. Okay, so what if I gave us an angle in the second quadrant? Maybe like something, 120 degrees, let's say. So it would be somewhere in here. So I'll draw 120 degrees would be somewhere between 90 and 180. But just as before, we're going to drop the perpendicular to the x-axis always. So this would be my new theta. It's between your angle and the x-axis is always theta. It's inside the triangle. Make a note to yourself. Theta is always inside the triangle at the center. So first it was here, now it's here for a different angle. So let's label x, y, and r. Now my horizontal side, my x, is actually, if you think about it, normally my x-axis, the positive values are on the right, and the negative x values are on the left. In the same way, If my leg is going backwards on the x-axis, I'll label that negative x. And for my y value, since I'm above, right, all the y values in this region are positive. So since I'm above, that'll be positive y. And then as always, r is our hypotenuse. Okay, in quadrant 3, let's say I am at, I don't know, like 225 degrees. That would be between 180 and 270. Drop the perpendicular to the x-axis. This will be a negative x. And this time we're seeing for the first time a negative y because we're going down. And then r is our hypotenuse as before. Lastly, in the fourth quadrant, drop the perpendicular. We have a positive x here. And then we have a negative y because we're going down. All the y values in these two quadrants are negative because they're below the axis. And then we have r. And notice that r is always positive. We never changed its sign. So please commit that to memory. While x and y can change based on their location, r is always positive. So now that we got that down, we can do our first example. We're actually, I want to talk about x, y, and r really quick. So if sine theta is y over r, then if you see something like this, look at this example. It says sine theta is 2 over 3. That means that this is y over r. That means y is going to be 2, and my r would be 3. If it says cosine theta is negative radical 2 over 2, well, cosine, look at your formula here, is x over r. That means that my x would be negative radical 2, and r would have to be the denominator, 2. And then lastly, tangent. The formula is y over x. So I'm going to write y over x. But what's missing here? Well, I'm missing a denominator, so we have to write that in. It's always over 1 if there is no denominator. And so we can see that y is positive 2, and x would be the 1. So let's do exactly that for example 1. Okay, ignore these rules on the right side right now. We're just going to label our x's, y's, and r for sine theta. So we know that sine theta is really y over r. So I'm going to write that in. So my y is 5, my r is 13. And I need to now draw the triangle created by this trig ratio here. So step 1 is actually complete. I labeled my x, y, and r, or at least the ones that I have. Now we're going to draw this in the proper quadrant. So this is going to tell you which quadrant we're in. If I'm between 0 degrees and 90 degrees, that means I'm going to be here in quadrant 1. So I'm going to draw. I'm going to be somewhere in this quadrant, and then immediately drop the perpendicular to the x-axis. That's what this is saying. Drop the perpendicular to the x-axis. Never to the y. Okay, next step, we have to label our sides. So if my y is 5, the y represents the vertical side. So this is going to be 5 here. And then if r is 13, remember, r is your hypotenuse always. So we'll label this side 13. Well, we need to find the length of the missing side. If this is my y and this is my r, then we need to solve for this horizontal piece, which is x. So I can use the Pythagorean theorem, which says x squared plus y squared equals r squared. So let's solve it and plug it in. So x squared, well, I don't know what x is. I'm solving for that, so I'll leave it. Plus y squared, y is 5. And then r is 13, so 13 squared. Keep in mind, we need to solve for the missing side. We need to get x by itself. So in our next step, x squared plus 25 equals 169. I just did 5 times 5, 13 times 13. We will subtract 25 on both sides, and I'll get x squared equals 144. We're almost finished. I need to get x by itself. So if I have x squared, I need to take the square roots on both sides, and I'll get x is equal to 12. And that would be our answer. So you can write down these 3 steps to help you with these problems. But basically, the first thing you always want to do is label your x, y's, and r's. Then, using this information, draw your angle in the right quadrant. Drop the perpendicular to create a right triangle. And then we're going to use the Pythagorean theorem to solve for the missing side. Let's do another example. This is number 1C. So as before, we're going to label first. Label, label, label. Number 1, label x, y, r. Step 2, draw the triangle. And then step 3, we're going to solve. We're going to label the sides again and go from there. So cosine theta is -1/2. My first step is to remember the formula for cosine theta. Cosine theta equals x over r. So I know this is going to be my horizontal leg, and this is going to be my hypotenuse. But which quadrant are we in? Well, let's look over here. If I'm between 90 degrees and 180 degrees, that means I'll be in the second quadrant right around here. So I'll draw an angle in the second quadrant and drop the perpendicular to the x-axis. So theta is always going to go inside your triangle at the center, just like that. Now, I have my triangle, I just need to label my sides. So x, it says, is -1. Well, this is my x side. R is 2. That would be my hypotenuse. So I need to solve for this piece right here. If this is x and this is r, then what I need to solve for is y. So again, if we have 2 sides of a right triangle, we can use our Pythagorean theorem to solve for the third. So let's plug in what we know. X is -1. So the -1 shows me that I'm actually going to the left. But really, when I talk about side lengths, this distance is just 1. So since we're going to do some math with this negative, I'm just going to ask you to drop the negative. Don't worry about it. Just do 1 squared, because this distance is really just 1. We're talking about lengths after all. Plus y squared, I don't know what y is, so let's leave it like that, equals 2 squared. So when we're using the Pythagorean theorem, it's okay to drop the negative. If you think about it, -1 squared is going to become +1 anyway. Anytime you square, the negative turns positive, so don't worry about even using it. Just drop the negative. Next step. 1 squared is 1 plus y squared equals 4. I'm trying to get y by itself, so a -1 on both sides. I get y squared equal to 3. And in the last step, I need to square root both sides. So y equals the square root of 3. And then I just want to do a quick check to see if this makes sense. If I'm in this quadrant over here, my x would always be negative, so I go backwards, and then my y will always be positive. So I did want to check that my y is +3. So our final answer, y equals square root 3. Cool, so we're done with our first problem, number 1. Let's go to number 2. Okay, we're going to be doing some math with our calculator for number 2. So make sure your calculator right now is in degree mode, however you can do that. If it takes a quick Google search, just make sure your calculator is in degree mode. Now, here, it's a slightly different problem because now I'm given theta. I actually know that this is 37 degrees, and I'm asked to solve for x. So now, since we're dealing with angles, we're going to have to use our trig ratios. Sine theta is y over r, cosine theta is x over r, and tan theta is y over x. So in order to solve for x here, I'm going to need to use one of these trig ratios. Well, let's see what they've given me. We're going to always, step one is always label everything, x, y, and r. So this guy I already know is x. This side is y. I need to set up a relationship. I need to choose the right trig ratio that is going to use what they've given me, which is y, and that what I need to solve for, which is x. The only one of these that uses x and y is tangent. So I'm going to set up a relationship using tan theta equals y over x, and we'll solve from there. So actually, we can fill in theta because we know the angle, it's right there. We can also fill in y because it's given right over here. Then the only thing we'll have to solve for is x. So let's fill in what we know. Tangent of 37 degrees equals y, that's 3, over x. Next step, I need to solve for x. To get x out of the denominator, I need to multiply both sides by it. That will get rid of it over here, and I'll have tangent of 37 degrees, x times tangent of 37 degrees, equals 3. In my next step, I still need to get x by itself. Right now, I'm multiplying it by tan 37. So to get it by itself, I'll need to divide both sides by tan of 37. Now I use my calculator and just type into it x equals 3 over, or divided by tangent of 37, and let's see what we get. So I'm going to try it on my calculator over here. 3 divided by tangent of 37. Okay, so 3 divided by tangent of 37 degrees gives me 3.9811. So that would be my answer. X equals 3.9811, and that is the length of this side. So we're good. That was number 2. So really quickly before I move on, I want to make sure that we got that skill down because just one example might not be enough sometimes. So if I gave you these problems, let's say to practice, these are all similar to number 2. Here they're giving me x and they're giving me r. So I need to choose the relationship that uses r and x. If you have them in front of you, you'll remember that's cosine theta equals x over r. So then you'll set it up like this. Cosine of 20 degrees equals x over 5. And then you'll solve for x by multiplying both sides by 5 and plugging that into the calculator. The next example gives me, this would be x over here, and this is actually mislabeled. This is really r. So since that's what I need to solve for, again, x and r, I'll use cosine again. Cosine theta equals x over r. So it would be cosine of 15 degrees equals 4 over r. That's my x, that's my r. And then in this last example, I'm asked to solve for x, and I'm given y. So the one that uses x and y, if you recall, is tangent theta, because it's y over x. So you'll say tangent of 30 degrees equals y, which is 8 over x. That's what I mean by select the correct relationship. Look at what you're given, what you need to solve for, and then choose the trig ratio that has the right letters that match. Okay, let's move on to number 3. 3 says, use the appropriate trig function to find the measure of the angle. So again, it's helpful to label everything that they're giving me. This is my x, this is my y. So which relationship Is it sine, cosine, or tangent? Which one uses x and y? If you said tangent, then good for you. You're remembering. So we'll write out the formula. Tangent theta equals y over x, and plug in what we know. So my y is 6 and my x is -8. And now I actually need to solve for the angle. I'm going to put a pause right here because this is a skill we haven't talked about yet. So really quickly, you should take this into your notes. To solve for theta, anytime you're given something that looks like this, so tangent theta equals some number, sine theta equals some number, anytime you actually need to solve for theta, we're going to do it like this. Right now, theta is stuck inside of this trig function sine. So what I want to do is move sine to the other side, essentially. If I had like theta plus 90 degrees equals 270, you would tell me to minus 90 on both sides to get theta by itself, because adding and subtracting are inverse operations. If I had 3 times theta equals 180 degrees, how would I get theta by itself? Right now it's being multiplied. Then you would tell me to divide by 3, because multiplication and division are inverse operations. So actually, sine, cosine, and tangent also have an inverse operation. And it has a really hard name. I don't know if you'll ever be able to remember it, but the inverse of sine, to get it to the other side, is called sine inverse. I know, very, very tough to remember. Sine inverse, I don't know. I'm obviously being sarcastic, right? It's a very easy name to remember. It looks like this -1 exponent, but it's pronounced sine inverse. So we're going to move sine to the other side, and when it crosses this equal sign, it takes on the inverse notation. And so we're left with theta on the left side equals sine inverse of 1/2. So imagine like we crossed it out from here, we moved it to the other side. Theta equals sine inverse of 1/2. And we can actually use our calculator to see what that is. So in order to use, where'd it go? Your calculator, you actually don't see that button here. So you have to press second and then sine. Let me clear. Clear, clear, clear. So to see the sine inverse button, you have to press the second key first. Second, and then you'll see the sine inverse. And then you just type 1 divided by 2, close the parentheses, and we get 30 degrees. So over here, I found out theta equals 30 degrees. Here's another example. Cosine theta equals -0.8. So again, if I want to solve for theta and get it all by itself, I need to take my cosine, move it to the other side. As it crosses this equal sign, it takes on the inverse notation. So theta equals cosine inverse of -0.8. I just want to let you know right now, as before, when we're doing math with these with the negatives, we're just going to drop the negative, because the calculator actually kind of freaks out when you put a negative here. So make a note. Drop the negative when using cosine inverse, sine inverse, and tan inverse. So we're really just going to go to our calculator and type in cosine inverse of 0.8. So again, press second, this time cosine of 0.8, and the answer is 36.87 degrees. So theta equals 36.7 degrees, or 87. So last example, if I want to solve for theta, I want to move tangent to the other side. So we'll do tan inverse of -1. But as we said before, we want to drop the negative when using our calculator here. So just tan inverse of 1. Let's see how that is on a calculator. Don't forget to hit second first, so second, and then you'll see the tan inverse button of 1. And we should get 45 degrees. Check it with me. If you're getting different answers, maybe make sure that your calculator's in number 1, it should be in degree mode. And then number 2, hit second and then sine, cosine, or tangent to see the -1 at the top. So that's how we solve for theta. So coming back to this example, if I want to get theta by itself, then I need to take tan and move it to the other side. So theta equals tan inverse of -6/8. To use our calculator, we're going to drop the negative. So we're just going to type in theta equals tan inverse of regular old positive 6/8. So right now if you hit tan 6/8, whoops, clear. If I just hit tan 6 divided by 8, and you see this is not the answer I'm looking for. Remember, we're asking for tan inverse, not tangent. So you need to hit the second key first, hit tan inverse, and then divide. The real answer you should get is 36.87. 36 degrees. All right, I hope that was helpful for you, and I'll catch you next time.